Then for acceleration, you're going to use dv dx. So that's the third step. Okay? That's the third step. And then you will use integration to get v out of here. You will use integration to get v out of this differential equation. Okay? So let's come back to this question. We said this resistance is proportional to the velocity. So how do you change a proportional sign to an equal sign? By a constant. Okay? This constant can be always in terms of x. Let's say this constant is, let's say a, or let's say this constant is b, right? This is a constant. B can be always written. It's moving in this direction. So in that direction, the acceleration is x double dot. And the force R is mkv. So if I use this, this is mkv. And the displacement was x. The velocity is v meters per second. Now we are going to use Newton's second law. What's Newton's second law? So you will write, say you are applying Newton's second law. Newton's second law is to deal with force, mass and acceleration. These two are vector quantities. So you need to specify the direction in which you are applying the Newton's law. Okay? I'm going to apply Newton's law in this direction. So I'm telling you this is the direction I'm applying this law. So always show the direction where you're applying the Newton's law. So in that direction, what's the force? The force is acting on this direction, but I'm applying the law in that direction. So what's the force? Minus mkv. Force equals mass times acceleration. So we have got the equation of motion. So that's the second step. So force diagram and then the equation of motion. So going from there. So if I have this here, x double dot is kv. So if you want to find the velocity in terms of time for the acceleration, what formula will you use? Right? For acceleration, either you use this or use this. This, if you want to find the velocity in terms of displacement. Okay? How do we solve this? Yeah, we integrate. So if you integrate with respect to, then you need to say integrating with respect to v, then so we are integrating with respect to v. Yeah. Integrating with respect to v. So it's important for you to say you are integrating with respect to what? Because sometimes we'll integrate with respect to time, sometimes we'll integrate with respect to v. Okay, so if you integrate, you're going to get t. Because you're differentiating and then integrating, you go back to square one, which is t. This one 1 over v is okay. Now how are you going to find c? We're going to use the initial condition where the particle was, the velocity was this, and that's the initial one, and the displacement was 0. So those are the initial conditions. So in your force diagram, I want you to write the initial conditions as well. So now I'm going to say when t is 0, V is capital V. If C is going to be
why doesn't the left integral get a constant when you integrate?
okay, if you've got a constant here, that V minus D, that's again a constant, I call it C. So, okay. So if you put it back here, T is going to be ln capital V minus, so, okay, log A minus log B. So how do you get V in terms of T? That was the question. So you will say, okay, this is KT. So V over V is e to the KT. So V is V minus KT. Okay? So I have shown you how to get the velocity in terms of time. Can you get the velocity in terms of x? Do you want to try it?
Yeah.
How do you get the velocity in terms of x? To get the velocity in terms of time, I used this one, right? I used dv dt. To get the velocity in terms of x, what formula will you use for the acceleration?
V dv over dx.
Yeah, v dv dx. Do you want to try it and get the expression for the displacement?
So you can't have a go. Have a go yourself. You can't when you start up. Thanks, mate.
So you're going to start off from the equation. Okay, start from there. Yeah.
In the circle dv on dt equals negative k on v, is there, can you just integrate that in terms of t? Why did you have to flip it and then integrate it in terms of v?
So how will you integrate v in terms of t? So if you integrate in terms of t, what you're saying is this, right?
Yeah.
How will you integrate v in terms of t? We don't know. We don't know the expression for v in terms of t. So you can't integrate v with respect to t.
Okay, thank you.
Any other questions?
I'm just wondering.
Yeah.
Can we turn v into dx over dt?
It depends on what you're trying to work out. We are trying to work out v in terms of t. That was the question.
Yeah.
If you put x in it, you're going to work out v in terms of it. That's what you're going to do there.
Yeah.
Yeah. So, if you ask to find the velocity in terms of displacement, you're going to use okay. So integrating with respect to x, you can get the answer. How about going from here? How about going from here? Do we need to write the equation again and solve it? Or can we go from here? This is the first part. So you can say instead of v, you can say dx dt. So dx dt is v, capital V. And so integrate both sides with respect to time and see what you get, rather than in there. Sometimes we need to use what we got from the previous part. We don't need to do it all over again. Now that we have got v here, make this dx dt.
So why does it become a negative?
Huh? Oh, no negative, sorry. Otherwise, it would be like a telegraphic language. Yeah, it's better if they say exactly So integrating with respect to t. So that's going to give you x, and that's going to give you constant. T is 0, x is 0, initial conditions. So C becomes, so if you put all together, you're going to have V over K, 1 minus e to the minus kt. So we have got the displacement in terms of time. We've got the velocity in terms of time. We've got the displacement in terms of time. Okay. So from here, what will happen as t approaches infinity? After a long time, what will happen to the displacement?
Goes to VRK.
If t goes to infinity, e to the negative infinity
Oh,
is 0.
yeah.
It approaches 0. So x will approach v over. So the displacement can never be more than capital V over K. Okay? The retarding force decreases with decreasing velocity, isn't it? It keeps on decreasing. It's like an infinite series. Okay, it becomes half, quarter, 1/8, and so on. So something like that. Okay. Now I'm going to do a small change in this, and I want you to do it all by yourself. So in the second question, the force is, the resistance is proportional to the velocity squared. And the initial velocity let's call it u. Okay. Initial velocity is u, the resistance is this. I want you to get the velocity in terms of time, velocity as a function of time, and the displacement as a function of time as well. Try this. See how far you can go. The resistance is proportional to the velocity squared. The find the velocity in terms of time,
That's very important.
find the displacement in terms of time.
I'll not do all that.
Okay, what do you do first? Draw a force diagram. Draw the force diagram. Go through those steps so you will be showing all your working rather than starting somewhere random. First, so this is the particle, no displacement yet. This is the time we start, and the velocity was u meters per second. So it goes, and then at some point in time, let's say the displacement is x, and its time is t. So let's say the velocity is v meters per second, and this retarding force, the resistance force, is proportional to this, so you say mkv squared. So that's the force diagram. You need to show all of them. The force diagram must show the initial conditions, and somewhere in its movement, when the displacement is x, velocity is this, and the resistance is this. Yeah.
Is there a reason that mkv squared isn't minus? Is it supposed to be?
That's why we put the direction. When you say plus minus for the forces, you need to specify the direction. So I showed this direction, it's a resistance. Okay. So what do you do next?
If you go here and
Yeah, equation of motion, right? So this is the force diagram. Second is the equation of motion. When it's the equation of motion, we are going to use Newton's second law, which deals with vector quantities. So you need to show the direction in which you are applying the Newton's law. So you will say, so I'm going to use this direction. Can someone tell me why I'm using this direction? I'm measuring the displacement from here. Isn't it? X goes this direction, so the acceleration is x double dot. If I use that direction and measure x this way, it's going to be minus x double dot. Okay? Okay. So force equals, what's a force? Minus mk v squared equals this. Okay? In that direction, the force is negative because force is acting on this direction. So beware of what symbol plus or minus that you use. Can I go from here? So get velocity in terms of time. Yeah.
If you say that the force going this way is equal to the force mkv squared, wouldn't that mean just like the particle just like stop?
If you use a force that way?
No, if like the mkv squared going this way is the same as going the other way, they're equal, the force is equal, wouldn't the particle just stop in the middle?
There's no force pushing that way.
You mean another force acting this way?
I mean, for the first particle,
For the first particle, yeah.
if you let the force of that equals negative mkv squared,
Negative which direction? Force is a vector quantity. Direction is important. It's
negative,
not plus or minus. Direction, yeah. This way.
yeah.
Now when the particle goes that way, how will the resistance act? It will be opposing. It opposes the motion, right? So if the velocity is in this direction, the resistance should be in that direction. Because it reduces, it's a resistance. It reduces the velocity. The particle is going that way. I'm going to slow down a bit, so I'll pull this way. Did I answer your question?
Yeah, and then if you use F equals ma, and the
Yeah.
force going this way, is the
Force is going this way. It's a resistance. Particle is moving this way. It's a resistance. Resistance means it opposes the motion of the particle, so the force is acting on that. If the particle is that way,
I see.
then it will be accelerated.
what about the force of the original?
Yeah,
Ah,
it was acting
wait.
that way always.
Oh, you mean it's like the force that pushes you, like that makes you go that way?
Yeah,
So-
yeah. If there's a force acting that way, then it's not resistance. It's accelerating force.
Oh, I thought, so it's one particle, right? One particle going forward and then getting pushed back. Is that it? I was thinking of as two particles colliding.
Say for example, it was like this, right?
Is that not it?
It was like this.
Yeah.
It's moving and it's stopping. Why? Because
Resistance?
of which way the resistance will act?
This
This
is
way.
that way.
This way.
Yeah.
Which way the particle is moving? That way. So the particle is moving that way, the resistance acting that
Oh.
way. So the
Oh,
velocity
yeah, I
will
got it,
increase.
yeah. I thought it was two blocks colliding into each other. Like the resistance was like the different block hitting the other block to make it big.
Now this is the initial condition. There are no two blocks.
Yeah.
The same block is moving.
Yeah.
Okay? All right. Okay, solve this. So going from here, x double dot is minus k v squared. I asked you to find v in terms of t. So what formula will you use for the acceleration? dv dt. How do you get v out of here? Out of this differential equation, how do you get v? So from here, you will find if you do all those things. So dt over so if you integrate with respect to v, that's what that is. I moved the k is a constant. Okay. You could have kept the k here if you wanted, or you could have kept the minus there if you wanted. Okay. So that will be kt. What's the integral of 1 over v squared? Huh?
What would be
Okay, how do you get c?
So then
Initial
it's already-
The
condition.
name's already there.
Thank you. Sorry?
Initial condition.
Yeah. When t was 0, v was u, right? Here, when t was 0, v was u. So use that. So what's c?
Minus.
Yeah. If you put it back here and rewrite it, it's going to be Can you make v the subject of the formula? Make v the subject of the formula. So v is going to be so we have got v in terms of t. So from here, if you make v the subject of the formula, you will get this. I want you to do the second part. Displacement in terms of time. Displacement in terms of time. See whether you get this result. Okay, I will give you the answer. 1 over k log ln 1 plus k u t. Okay. See whether you get the answer.
So is the initial velocity?
Initial velocity.
It's not very constant, right?
As it goes, as time.
Exactly, let's start right.
Okay, so, yeah, have you all solved this for the displacement? Anyone get it? Okay. Now I'm going to give you a question from your Fitzpatrick book. That'll be the last one for today. Do you want to try this? I'm not going to write full sentences. I'll say, what's the difference between mass and weight?
One is force, one is mass.
The mass or in our day-to-day languages it's the same, but mathematically they are different. Okay? Weight is a force, the gravitational force acting on the particle. Mass is the amount of matter. So mass doesn't change. If you take it to the moon, it doesn't change. The weight will change according to the gravity. So there's a particle of unit mass, and the resistance is proportional to V plus V cubed. V is the velocity. So initial conditions so that's the information given to you. I want you to find, okay, first show that the displacement is inverse tan q minus v over 1 plus qv. Second part, time is half ln a squared 1 plus v squared over v squared 1 plus q squared. Okay. Third, along its path, when the displacement is x meters, the velocity is v meters per second, and the resistant force is R. R is K V plus V cubed. Okay? V plus V cubed. So that's a force diagram that you will draw. Second, write the equation of motion. One and only law that we use is Newton's second. So that's all your mechanics. The rest is all your integration. You have done a lot of integration. The rest is so mechanics is just one line here. Equation of motion is the only mechanics. So it's all integration. Okay. So equation of motion, you need to say the direction where you are applying the Newton's second law. Force. Because mass is 1 times acceleration. When the displacement is x that way, acceleration is positive x double dot. Okay? You asked to find the displacement in terms of velocity. So for acceleration, what formula will you use? The question says it's numerically equal to, so k is 1, so leave the k. It says numerically equal to, so k is given to you as 1, so leave the k. Okay? It says numerically equal to, the resistance is numerically equal to v plus v cubed. It didn't say it's proportional to v cubed. Okay, so write this question here. It says numerically equal to, it didn't say proportional to. So k is 1. So that's the second part. Third part, you look at what they're asking, x and v. So for acceleration, you will use v dv dx. This minus v plus v cubed. Okay? So if you integrate both sides with respect to v, so there's a v here common, right? So that v and that v cancels out. We go like this. So integrating dx integrating with respect to v. Integrating with respect to v, so dv. So this will give you x. This you know is inverse tan, isn't it? Then use the initial conditions. X is 0, and v is q. So c becomes inverse tan q. Okay? C becomes inverse tan q. So if you put it back here, you're going to get x equals inverse tan q minus inverse tan B. You remember tan A minus tan B?
Yep.
So inverse tan Q minus inverse tan Q is inverse tan A minus tan B over 1 plus tan A tan B. So that's what you asked to prove, okay? You all know this, right? Inverse tan minus inverse tan is, yeah? Does anyone need any help with this? So that's, okay, do part 2.
So,
Hmm?
since the forces, that not proportional to equal to the where does that from if you present like what is the mass go?
Mass is 1 unit mass.
I remember the 10 inverse A minus 10 inverse B.
Okay. Can I do it on this side?
Yes.